Hi, I'm Michael Marty, and I'm an assistant professor from the University of Arizona. I'm not in Arizona today. I'm in Columbus, Ohio at the National Resource for Native MS Guided Structural Biology. And I'm going to give you a tutorial today on our software called UniDec. It's short for Universal Deconvolution. And it's meant to be a tool to help you analyze electrospray mass spectrometry data. And we built it really for native mass spectrometry, but it also works for denatured proteins as well. So why use UniDec? Well, it's totally free. It's very fast. It provides a lot of flexibility in the types of analyses you can do. And also, I think it provides a pretty friendly way to get your data out, to do various sorts of data analyses, to extract information on mass, charge, intensity, all of these things. So over time, we're going to be doing more of these tutorials, but today we're just going to give a very quick intro to how you use the software, how to get started, and some very basic parameters. So over here, I've downloaded UniDec from the web. You can find us on GitHub. You can search for UniDec or look for my website. When you download it, you're going to get a zip file. Now, you don't need to install anything. You just unzip this file. You're going to get a folder that's going to look like this. You open it up. Now, there's a lot of files in here. The one you want is called GUI UniDec. And so if you double click that, it's going to launch the background and then the front end of UniDec. And there are a variety of different tools built into the UniDec package, but we're just going to start with a very basic one today. So when you open it up, you're going to see a window like this, and the first thing that we need to do is load in our data. Now, there are a variety of ways to get data into the software. Perhaps the easiest is to open it in MassLinks or Qual Browser or whatever type of vendor-specific software you use. Most will allow you to copy paste data out of there. So in Qual Browser, which is what we use fairly often from Thermo, you right click on a spectrum, you click export, and then you click clipboard exact mass, and that's going to export that to the clipboard. From there you can go in UniDec and do file, get spectrum from clipboard. In MassLinks, you go up to edit and click copy spectrum list. So it's pretty simple to get it out. And we use this on the instrument all the time. So we have the data collection open, we have UniDec open, and we just quickly copy paste between the two. When we're ready to do sort of more thorough data analysis after we've collected the data, UniDec will open MZML. It'll open text files where you just have an XY list of the mass and the intensity. It'll also open thermo and waters data, but you're going to need to install some special libraries from them to be able to convert it. So with thermo data, you need to install MS File Reader. With waters data, you need to download the waters MassLinks DLLs. And the more information is on the UniDec website on how to find that. You can also email me to get more information. Today I'm just going to show you some example data. So we've loaded some example data in. These are present as text files. I'm just going to show you a very simple spectrum with BSA. You see here, this is our mass spectrum. And it's, we have a pretty broad MZ range. We don't really care about that. The first thing I'm going to do is go into the presets, and I'm going to select high resolution native, which is a pretty good preset for here. And then I might go over here and quickly adjust the MZ range to be something like 2500 up to, say, 7500. And I'm going to click process data, and that's going to then set the data range that we want to look at over here. We can also do things like background subtraction or downsample the data by binning some data points together, which helps smooth things. Now you can see we haven't quite hit the range we want, so I'm going to zoom in closer here, and then I'm going to right click. And what right clicking does is it sets the MZ range to what we see over here in the plot. So then I'm going to click process data again, and now we see we've got the right MZ range here. Okay, the next step is to just simply run UniDec. And from the default deconvolution parameters, we're just going to hit run and see what happens. And you can see it takes about a second to run the deconvolution. It looks like 0.5 seconds here. It takes a few seconds to plot all the results, but it's pretty fast, right? We've done a really high resolution scan, deconvolved it really quickly. And there are a few plots you can see here. So over here we have our zero charge mass spectrum. This is where we've taken the charge out and we've plotted it with all the charge states summed together. This is in pure mass, so in mass of kilodaltons. Over here we have two separate plots. They're two-dimensional. One is mass over charge on this axis versus charge on the y-axis. And you can see we have a couple bright spots here. And these correspond to the three major charge states of BSA. So we have one that's at plus 14, one at plus 15, and one at plus 16. And if you have normal electrospray spectra of larger complexes, you're going to see sort of a swoop in this m over z versus charge plot, because as you go to lower charge, you're going to higher mz. Now, down here, what we have is mass on this axis, which is the same as this spectrum up here, versus charge. And you can see we have one sort of blob, which corresponds to the major charge states and the major masses for BSA. So we have a mass of about 66 kilodaltons, and this is distributed about 14, 15, 16 charges. So it's just two different ways to view the data. Now, once you've got your deconvolution, you can go over and select your peaks. So we just click the peak detection over here. It's set by both the window, so we're telling it a peak must be a local maximum plus or minus 500 daltons. We also set a threshold. So we set a threshold here of 1% or 0.01. Now, if we wanted to pick more peaks, because you can zoom in and see, well, there are more peaks here, you can either lower the threshold to say 50, and then you're going to see we pick more peaks. We have these here. Or we can lower the threshold or change the threshold. So say we only want to see these top few peaks, we could raise this to maybe 0.05 and set this to 20. And now we're going to see we're just catching these two peaks here. So there's a lot of different ways you can play with this. Some other useful parameters to consider on the side are things like the charge range or the mass range. So for example, on this plot here, we can see there are a lot of charge states that we're considering that we really don't need to. So if we set the charge range from 10 to 30, we're going to get a little bit faster deconvolution and a little bit easier to read spectrum over here. We can also say that the mass range is going to be from, say, 60 kilodaltons up into, say, 140. We're also telling it to sample the mass every 10 daltons, which if you zoom in here, you can see, well, it's maybe not the best. It's kind of coarse. There's only a few data points per peak. Let's sample it instead every dalton. And so if we put that in, you're going to see a smoother distribution over here. It's going to take maybe a little bit longer to plot, but still not too bad. So when you zoom in now, we've got more data points per peak. And also, we're going to have a more accurate deconvolution because the mass that we get over here is always limited by the range in our mass sampling. So you can see here in this panel, we have a variety of different peaks. We can right-click on any of these and get a variety of options, like we can label the charge states so that you see down here which charge states are which. We can also look at things like the uncertainty. We can look at the differences between the peaks. So if we click this main peak and click show differences, it will show us that these two peaks here, actually going to reselect that just to make it a little bit easier. If we click that, click display differences, you can see, yeah, that these two peaks, one is at plus 119, one is at plus 166 away from this central peak. So there's a lot of different analyses you can do. Down here is some more information on the peaks. So you can see this is the MZ plot with the peaks annotated. So it will show you, which peaks on the MZ belong to which masses in the deconvolution. This will show you the intensities of these. We can also get the areas if we integrate. So if you go to analysis, integrate peaks, you can get the peak area. Let's see. Yep. Yes, and the final thing I'll show you is that if you click plot peaks over here, you can get sort of nice distributions here that show you which peaks belong to which series. So I think that's a pretty good introductory tutorial. It should show you some of the basics of how to use UniDec. There's a lot of features built in, and over the next, probably few years, where we're funded by our NSF grant, we're going to be developing some new tutorials to show you how to use some more advanced features. But as always, I'm happy to answer questions by email. We hope you find the software useful, and thanks to Vicky for hosting us here and for helping us make the video, and we look forward to good deconvolution for everybody in the future. Thank you.